Alright class, so in this lesson starting chapter 6, lesson 1, and really what you're going to be doing throughout this whole chapter, you're going to learn what a system of equations is and the various methods that we use in order to solve a system of equations. Okay, so very simple when we talk about a system of equations, that means that you have two linear equations. Okay, two linear equations, so as it states here exactly what it is. The ordered pair that is a solution to two linear equations is the solution of the system. So actually the system of equations itself is actually the two linear equations. The solution is going to be where those lines cross each other, because we know that with a linear equation, when we graph it, we get a straight line. So here, whenever we have a system of equations, then we have two linear equations, and when we graph both of them, typically they're going to cross at some point. So the point at which they intersect, that ordered pair is the solution to that system of equations. Okay? Now, there are different kinds. As we see here, it says you can have three types of possible solutions. You can have a one solution, you can have infinitely many solutions, and you can have no solution. All right? So those are the three possible solutions. Now, there are also types. Now, this is separate. Okay, this is separate. But these are the different types of equations. You have consistent, and under that heading of consistent, we have consistent independent. So when we have consistent independent, that type, we have exactly one solution. When we have consistent dependent, then we have what's called an infinite number of solutions. Okay, we've kind of dealt with those before. But then we have inconsistent system of equations, and that is a no solution. Of course, we've dealt with those with equations in the past. Okay, so let's take a look at each of those, and then we're also going to take a look at the different possible solutions. As I talked about here, we have one solution, infinitely many solutions, no solution. So those are all the different types of solutions. Okay, and then the second part, once again, these are the types of equations. So those are two different things. All right, so let's take a look at the different types. So here we have what's called a consistent independent. So consistent independent, that just means they cross at one point. So I have my linear functions here, and they cross at one point, and that solution would be consistent independent, meaning 1. Independent means 1. So we have negative 10, positive 2, and that would be your solution. The type is consistent independent. So those are two separate things. We have consistent independent, and then the solution itself is negative 10, positive 2. Okay, so let's take a look at this one. Now this is an example of consistent dependent. Okay, so if it is consistent dependent, then when you graph these, the lines are going to be exactly the same thing. One is going to land exactly right on top of the other. And so here, if you were to actually write out your solution for that, this is the one in which you would say you have an infinite amount of solutions. So infinitely many, or infinite many solutions. That would be your solution. This is the type. This is the solution. Okay? All right, so those are the first two, and then those are both consistent, the types of consistent. This is inconsistent. So when we say inconsistent, what you're going to end up with are two lines which are parallel. So if they're parallel, they never cross each other, so there's no possible solution when they don't cross each other. So your actual solution for this one, of course, would be no solution. They never cross. They never intersect. So since they never intersect, there is no possible solution. But the type is inconsistent. So inconsistent is always going to have a no solution. Now, up here also we notice that with the slope, anytime you notice the slopes of the inconsistent, the slope is always going to be the same. But yet, of course, the y-intercept is going to be different. Okay, so that's important. Slope is the same, y-intercept is different. Okay, so let's take a look at our first example. With this one here, if we're going to graph, we're going to look at our first one here. We're going to graph that one. So we're going to start at positive 10 on the y-axis. And then we have negative 3 over 1 for our slope. So I'm going to go down 3, 1, 2, 3, over to the right once, And do that again. 1, 2, 3, over to the right once. And then, of course, we're dealing with equations, so it's always going to be a solid line. Okay, let's do the second one. Now for the second one, I'm going to start at -2. And slope is 1 over 1. I think I'm a little bit off on this one. Yeah, I'm definitely off. But anyway, if I were to actually extend, okay, my line's crooked. So if I were to extend on the first line, I go down 3 again, 1, 2, 3 to the right one. Yeah, we noticed, it's just that my line happened to be crooked on that one. But where they would actually intersect, if I were to actually draw that straight, there we go, and draw the other one straight, they intersect at that point. Now, the type this would be, this is consistent independent. 1, consistent independent. The solution is 3, 1. Wherever they intersect, it's that ordered pair. So that would be your solution. The type would be consistent independent. Okay, so let's take a look at this one. Now on this one, we notice it is not in the form y equals mx plus b, so guess what? We got to put it in the form y equals mx plus b. So the first one up here, what I'm going to do on that one, I'm going to start off, subtract the 2x. So we get this. And then, of course, we have to divide by -1. So we end up with y is equal to 2x plus 1. That will be our first one. Second one, subtract the 4x. End up with -2y is equal to -4x plus 6. And then divide by -2. So we get y is equal to 2x minus 3. Okay, so now we have our two equations. Now we can graph. We got them both in slope-intercept form. So let's do that. So we're going to start with the first one. Start at 1. Rise up 2, run out 1. Do that a couple of times at least. And the other one, we got -3. Start there. Rise up 2, run out 1. Oh, what do we notice? Got the same exact slope, and we could actually see that in the equations, right? So on this, when we graph it, okay, we're going to see we have two lines which are parallel. So what's our solution? No solution, right? Yeah, no solution. They don't intersect. What type is it, though? Okay, the type it would be inconsistent. All right, so inconsistent, that is your type. Solution, no solution. They never intersect. Okay. All right, so last one here. Let's take a look at this one. So for this one, okay, we're going to start off same thing, and we're going to isolate the y. So on the very first one, we're going to subtract the 6x. So we get 3y is equal to -6x minus 9. Divide by 3. And we end up with -2x minus 3. Then for the second equation, all we have to do there is divide by 3. And we end up with y is equal to -2x. Well, what do we notice? We have the same exact thing. So I'll go ahead and graph it. But whenever you get the same exact equation, that is going to be consistent dependent. Okay, consistent dependent. So that's where you're going to have one line land exactly on top of the other one. Okay, and then for the other one, same thing. And there's going to be one right on top of the other. So that one is actually, your solution is infinitely many solutions. Okay, you have an infinite number, so you have tons of points, which are, of course, a line is made up of points, infinite number of points. So that's why we say infinitely many solutions when we have this. Now that would be your solution. Of course, once again, the type that you would have, that would be consistent dependent. Consistent dependent. Okay, so that pretty much wraps up lesson 6.1. And so once again, that's what you're going to be doing throughout this chapter is solving systems of equations and all the various methods and ways that you do that.